Hey, good morning, CP Math 1. This is Mr. Roberts at Shasta High, and 5 minutes, I'm going to take 5 minutes or less. I want to introduce another way to think about solving a system of equations. And to do that, I'm going to review the way that we've already been using. So far, we've been solving systems of equations using either the equal values method, that's one thing, or by using substitution. And I'm going to review how we would have solved this in the past using those methods. So if I want to solve this using substitution, I need to have either x or y alone in one of the equations. What I'm going to choose to do here is get y alone in this top equation. So I'm going to take this top equation and I'm going to rewrite it. I'm going to take away 2x from both sides. So it's going to become 3y equals negative 2x minus 2. And then I'm going to divide everything. Oops, my face is in the way. Then I'm going to divide everything by 3. When I do that, 3y becomes y, negative 2x becomes negative 2/3 x, and negative 2 becomes negative 2/3. So I now know what y is, right? The first equation's giving me an expression for y. It's not a number, but it's a way I can represent y. This thing that I'm going to box in green is equivalent to y. Now, here's the thinking. This is the substitution moment. I can take this expression that equals y, and I could plug it into y in the second equation. So here's what that looks like. I take the second equation, which is 5x minus 3 times y. But I don't write y. What I do is I put instead what y is according to the first equation. Y is negative 2/3 x minus 2/3. There we go. We now know that this, let's not forget it equals 16, right? There we go. Now, this equation doesn't have any y's, it just has x's. So I'm going to distribute this negative 3. So that means that I'm going to multiply this negative 3 by both the negative 2/3 x, and I'm going to multiply it by the negative 2/3, the distributive property. So I'll go ahead and rewrite the 5x, but then negative 3 times negative 2/3 is going to become positive 2x plus 2x. And then negative 3 times negative 2/3 is going to become positive 2 plus 2, and that still equals 16. Looking good, looking good. Next, 5x and 2x is 7x. 7x plus 2 is 16. If I take away 2 from both sides, I get that 7x is 14. Divide both sides by 7. X must be the number 2. Okay, we know that x is 2. Now, I can use any of the equations that I started with, the first one or the second one, to figure out what y is. I'm going to just arbitrarily decide to use the very first equation, right? I'm going to use that equation and the fact that I just know that x is 2 to figure out what y is. So taking that first equation with the red dot, I'm going to write 2 times x plus 2 times x plus 3 times y. But I know that y is the number. Oh, no. I know what x is. I'm writing 2 times x. Hey, 2 times x. X is 2, right? 2 times x, which is 2 times 2. 2x is 2 times 2, plus 3y is negative 2. Okay, now I'm on the right page. 2 times 2 is 4, so this is 4 plus 3y is negative 2. If I take away 4 from both sides, I get 3y is negative 6. And if I divide both sides by 3, I get y must be the number negative 2. So my solution is the point where x is 2 and y is negative 2. That's where these two lines will meet. They meet at 2, negative 2. Now I know what you're thinking. That wasn't hard. I could follow that. I could do that. Why would we need a simpler method? Watch this. It's pretty slick. So the method is called the method of elimination, right? And the way this is set up, let me see, I'm going to grab this and make a copy of this problem. Let me bring my cursor over here, grab you. I'm going to copy this, and then I'll just come over here, and I'm going to paste that. So we just solved it using substitution, but I want you to look at this method that we're going to call the elimination method. So from the first equation, I know, and I can write quite comfortably that 2x plus 3y is equal to -2. Now, you and I both know that if I want to, I can add 16 to both sides of this equation. There's nothing wrong with adding 16 to both sides. If you have equal things and you add equal things, you get equal things. So I can add 16 to both sides. But here's the thing I could also add. According to this, 16 is the same thing as 5x minus 3. So I could add 5x minus 3y to the left-hand side, and I can add 16 to the right-hand side. Why can I do this? Well, because they're the same. Because I'm adding equal values to both sides, I'm going to get an equivalent equation. So on the right-hand side, when I have the -2 and I add 16, that's going to give me the number 14. And over on the other side, when I combine this positive 3y and the -3y, that equals 0. Y just got eliminated, is gone. There's no more y. 2x plus 5x is going to give me 7x. So this equation, just like that, becomes 7x equals 14. Therefore, x is the number 2. Now that I know that x is 2, I'm going to grab that, plug it into either one of the other equations. I think I'll use the second equation this time. The second equation says 5 times x, there it is, x is 2. 5 times x minus 3y is 16. 10 minus 3y is 16. Negative 3y is, Negative 3y is, I need to subtract 10 from both sides. Well, if I subtract 10 from both sides, it's going to give me 6. So negative 3y is 6. And now if I divide both sides by -3, I get that y equals -2. There you go. We got it twice. This time using the elimination method. So our solution is still x is 2, y is -2. But you can look at the work from the two different problems. The work is a lot cleaner the second time around using elimination. So this is the process when we used substitution. I had to get y alone in the first equation, and I substituted that into the second equation. Then I solved for x. Then I used that to find y. And this is what it looks like when we used elimination. You can see at the very, very beginning, this positive 3y and this negative 3y, and you can see them over here, right? They combined to form 0y. The y variable got eliminated. So the very first thing I could write down, right, the very first result is that this 7x equals 14, therefore x is 2. We know x is 2. I plug in x into the second equation and I get what y is. Elimination. That's the idea for the day.